Alrighty guys, welcome back to the shop. In today's video we're going to be making a 2-brick forge. These are extremely useful for novice and new knife makers, as well as those who want to travel with their forge, since no electricity will be required and its small footprint makes it easy to pack away in the car. Another major benefit of these little forges is that the only insulating material required are these fairly inexpensive bricks, which are easy to work with and easy to acquire. I will put links to these bricks as well as the pipe fittings and other components for this build in the description below for your convenience. As y'all have seen up to this point, I have marked out where I want my chamber to be, and I have started to remove material with a saw. Now this material is extremely soft, so it doesn't really take much cutting action to remove a large amount of material. Here I'm just using a general woodworking saw. You can see in this next clip I'm using a drywall saw to go back and knock down the bulk of the ridges, and after this I'll use a file to smooth everything out. In this case I am making a 2-inch in diameter chamber. I do think that this number can be increased with the amount of material you have on 2 blocks. I think you can probably get up to about a 2.5, maybe even a 3-inch chamber, so your needs will dictate how large your chamber is on your blocks. Once I have the chamber filed in, I will be putting a hole in the side of the forge to accept my burner. I am going to be putting this hole at a slight angle pointed towards the back of the forge, in this case a 20-degree angle. Some of you subscribers out there may have noticed by now that these early clips have been recycled from one of my more recent videos on how to make your first knife. In that video we heat treated the knife in the build with these 2 bricks and a butane torch. In this video, we're going to be building a burner that can be dedicated to this forge as a more permanent solution. That being said, if you're looking to heat treat your first knife, go ahead and use your butane torch to get a feel for this forge and to get your feet wet with the knife making process. While it may be slightly underpowered compared to what we'll build later in the video, it does get the knife up to heat treating temperatures, and you can have fun playing around with this arrangement. Next, we'll go over the components for our mini Venturi Frosty T style burner for our mini forge. It should be noted that on these brass components there are a multitude of different variations that could be used in order to make this burner work. However, these are the components that I had on hand, and I wanted a 90-degree elbow in my brass setup. I will say that I'm pretty sure there's a 3/8 flare by 1/8 of an inch male pipe thread union that you could purchase and negate a lot of these components. The first step is to drill a hole in the center of the top of our reducing T. To do this, I clamp the T down in my vise on my mini mill. However, the same operation could easily be done on a drill press. I drilled this hole stepping up to a 21/64 inch drill bit and then tapped it to 1/8 by 27 MPT threads. While keeping the part clamped into my vise, I used the tap in the chuck of my mini mill to get it started in a straight orientation to the T, and then finished out the tapping by hand. The 1/4 inch flare by 1/8 of an inch union that we will be threading into the hole we just tapped needs to also be tapped through the center. On the 1/8 of an inch side, without having the drill, you can go ahead and tap this to 1/4 by 28 NF thread. I tapped my union on my previous Venturi Frosty T burner build, and that is why you don't see me retapping it here. I want to note that in the last clip I showed a 35 thousandths MIG tip. I ended up using a 30 thousandths MIG tip for this construction. It's also worth mentioning that I am using the gas or propane rated Teflon tape to put all of this burner together. So in order, I start off by putting the 30 thousandths MIG tip threaded into the 1/8 of an inch by 1/4 flare fitting, then threading it into the T, using this 1/4 inch flare coupling, threaded into the elbow, and finally onto my union with 3/8 flare. I then put the nipple, which is about 4.5 inches, onto the reducing T. For demonstration purposes, I put this 3/4 of an inch to 1/2 inch reducer on the end so that when I lit it in the vise, the burner will hold the flame. When you actually put this burner into your forge, the forge chamber itself will be holding the flame, and this piece is not necessary. I then rigged up a little burner test with the 2 bricks that we will be using for our forge, just to see how this little guy does. It may be difficult to see in this video, but my air to gas ratio was a little bit off and my burner was burning very rich. To pull more air into the system, I will be reducing the length of the MIG tip. It is a good general practice for the MIG tip to be in the center of the reducing tee when you're looking at the burner from the side. So in this case, I'm taking off around 1/4 of an inch from the end of the MIG tip and then reinserting it into the tee. If you direct your attention to the footage in the top left of your screen, you can see that the MIG tip is now landing around the center of the reducing tee when looking at it from the side. This burn is much better than the rich burn I was getting before, and I think that this little burner is going to be a suitable option for this 2-brick forge. I then started cutting out the material I will be using for the rest of this build on my Bauer bandsaw. A cutoff wheel on a 4.5-inch angle grinder or a drop saw could also get this job done, but I decided to use the Bauer bandsaw because I had it set up. It's also worth noting that the material selection for building the frame around our forge can be slightly different depending on what you have in your shop. For instance, flat bar may not necessarily be your first option. You could use another piece of angle or even some small square tubing to get the same thing done. Just use what you have and build your forge based on the inspiration of this video, not necessarily exactly the way that I built it. I also want to come clean to you guys. If you haven't noticed by watching some of my other videos, I am not a welder. I do very basic welding and I can stick metal together, but it's generally not pretty. In this case, I am using a flux core wire welder, which already looks ugly just because of the amount of slag that it produces. On top of that, my skills are subpar, and you will be cringing if you are a welder watching this video. The level of precision required for building this frame is not very high, and you can build a little slop into the system. I made sure to put some shims on the pieces of angle going along the top of the bricks so that these bricks can slide in and out of my frame. I did this in case these bricks ever get damaged. I can easily replace these bricks just by ordering 2, taking the hole out in the center for the chamber, and then sliding them into my frame. I also decided to add the rails for a door in the front and the back of this mini forge. The doors will be constructed out of hard fire bricks, which are a little bit skinnier than the soft fire bricks we're using for the chamber. These work good for doors, however, they don't work great for forge bodies, so just keep that in mind. I will say that the door on the front of the forge was completely unnecessary and actually hindered the performance of the burner when I tried to close the front door later on in the testing. So if you're going to be building this forge, I would not put the front door on the forge just because I don't feel like it's necessary. The last difficult part of this build will be how we decide to attach the burner to the cage so that the burner is held in the proper orientation and doesn't damage the bricks over time. To do this, I took a 3/4 of an inch coupling and then tapped it to 1/4-20 on 2 sides for set screws. Looking back, I think a 3 set screw design 120 degrees apart from each other would probably be superior. Once I have the set screws tapped, I go ahead and grind a flat into this coupling so that it can rest on a piece of angle. This piece of angle will be holding the coupling up in its proper orientation. I hold the hole similarly where I want it and then scribe a line where I want the angle iron to be welded to the frame. I then line that angle iron up with that scribe, weld it to the frame, and then line it up again, weld the coupling onto the angle iron, and bam, you have it done. Once I have everything tacked together, I took the whole cage outside the shop to finish up my welds, and then I ground off the nasty slag and cleaned up my welds. I used some just run-of-the-mill paint here, but I would highly advise using a high-temp paint for this frame. Once your frame is done, you can slide all your bricks in and test out your forge. The paint actually took up a little bit of space, and getting these bricks back in was a little hairy, but they did eventually slide back into the cage. When you are inserting your burner into your forge, make sure that the tip of the burner is about 1/4 of an inch back from the wall of the chamber. This will allow the burner tip not to get damaged and for the chamber to act as a flame holder for your burner. When testing out this forge and burner, I ran the burner at about 1 to 2 psi on my propane tank. I actually got it all the way up to 5 psi at one point, but I found that that was highly unnecessary for the type of work that you likely do in this forge as a knife maker. Considering its size and the cost of materials, this little forge is extremely efficient and useful for the beginning knife maker or just the beginning blacksmith in general. If you guys liked this video and got something out of it, go ahead and hit that like button down below and consider subscribing to the channel. I also got with the times and recently started a Patreon account where I'll be posting exclusive templates for knife builds that I won't be putting anywhere else. So also check that out if you're interested. Until next time, I'll catch y'all on the flip side.